Welcome to Samir Critic. So now we have come to the another part of material generation or basically biomaterial generation of biomaterials in brief. So biomaterial has been classified into three generations based on their host response, based on their mechanical strength, and based on their interaction with the surrounding tissue. So first generation biomaterials are basically replacing tissue or replacing function with a low as possible interaction with the surrounding tissue. Those materials were found in the classic industrial market. Those materials were selected because of corrosion resistance, so high corrosive resistance, and basically they are used for supporting element with the supporting element of a fracture bones. Next comes to the example part. So basically the examples uh, of biomaterials are stainless steel, titanium, cobalt, chromium alloy. In polymer based first generation biomaterials are ultra high molecular weight polyethylene, polymethyl methacrylate, and ceramic base are alumina, zirconia, etc. Comes to the second generation biomaterial. So they are mostly bioactive in nature and stimulate the tissue repair and tissue growth. So first is metal. So this is like new beta titanium alloy or porous stainless steel or titanium based implant. Polymer based, basically biodegradable polymer based, a second generation biomaterials. And last is ceramic. So ceramic like bioactive glasses, hydroxyapatite. So those are under second generation biomaterials. And last one is third generation biomaterials for tissue engineering application. They are much more regenerative biomaterials in combination with the living cells. So basically they are bio absorbed, bioresorbable or bioabsorbable biomaterials. So they are biologically active materials, transformation in and formation of new tissue such as osteoinductive material. Osteoinductive material. Now different kinds of biomaterial are based on their origin. So they are mostly based on origin. First is your inorganic biomaterials. So this is defined as they are they but they are not so harmful with the biological system. Reaction between the tissue and materials are possible, but what I said before, they are not harmful. So not any kind of toxicity effect will take place. Another is bioactive or bioinert. So they are basically do not react with tissue. And last is bioactive biomaterials from inorganic point of view. So they simulate the tissue repair or growth. Now comes to the organic biomaterial part, or basically they from natural origin. We can say some of like collagen, heart valves from pigs, and some kind of transplantation like autograft, xenograft, and some few of the polymer based. Combination of inorganic in biomaterials, also some kind of inorganic and organic biomaterials. So combination of both means inorganic plus organic. So both combining with both, we are making some biomaterials also for better result. So basically we have categorized our biomaterial into the two pools. First one is the inorganic one and second one is our organic biomaterials. So inorganic are also classified into two, basically metal and ceramic, and organic are classified into the polymer groups. So biomaterials are classified as organic in content with carbon. Inorganic, they do not have carbon. More specifically, biomaterials fall into the means in greater character or greater classification. Uh, Biomaterials are classified into mostly three parts: metal, ceramic, and polymer. So metal or ceramics are basically comes from organic background, and polymer are basically comes from inorganic point of view. So as I have discussed, they are mostly categorized into the three pools: metal, ceramic, and polymer. But other classes of biomaterials are inorganic gases, composites, and natural biomaterials. Now the mostly common biomaterials are from metal categories: stainless steel, basically SS315 we have used, cobalt chromium alloy, and titanium. Under ceramic we have basically going through alumina or zirconia, Next to if I comes through the polymer based, so we are use polyethylene terephthalate or PET enormously. PET has been used for load bearing application. We have used ultra high molecular weight polyethylene, and for soft tissue engineering we have used silicon based polymer. So if I am mapping our biomaterials into a pie chart form, then we can see that if a synthetic biomaterials can be categorized into mostly three parts: metal, polymer, ceramic, as well as some sort of semiconductor material or silicon base. So in under polymer, so drug delivery devices, skin, ocular implants. So for skin and cartilage, ocular, and drug delivery devices, we have enormously used polymer based biomaterials. Under ceramic based biomaterials, we have used basically where the mechanical strength I require much more, like bone replacement and dental part. So this is mostly the ceramic based biomaterial are good fatigue strength as well. So they have good fatigue strength as well. Now comes to the metal part. So they are also used enormously with uh, moderate mechanical strength. For orthopedic screw and fixation, we have used metal based biomaterial, and dental implant as well. They are little bit cheap as well than our ceramic or composite based biomaterials. Now comes to the silicon biomaterials. So those are the biomaterials used as a biosensor, microelectrodes, some kind of skin grafting as well for silicon based biomaterial. But for semiconductor biomaterials, they are basically used for micro devices. So today basically I have discussed regarding the classes of biomaterials based on their origin and based on our demand, so that where we use which kind of biomaterial. So that's all for today.